Hello everyone and welcome back to our course here, and today we are going to discuss about the fundamentals of data science processing. In fact, fundamental steps in the data science processing. So we have seen very basics of data science fundamentals and some points on big data analytics, and this class today is going to lay a foundation for the other lectures that we have ahead. So what we are going to see today is, here is the overview. You can see various blocks. So at first we have to define the goal of our objective of our data science processing. For example, if our goal is to obtain a valuable information about, say, weather, then that's our goal. So what is the question that you are going to raise is very important in this part. Once you know the objective, then you can go ahead and collect the information. For example, you know your goal is about weather forecast, then you're going to collect the data related to weather. Then you're going to have a data preparation part where you are going to clean the unwanted data and so on. Then is the next step is data analysis. As you can see here, in data analysis process, again we have various models that you can build so that you can come up with needed predictions if needed, or come up with the right model for our goal. Then to visualize the results, we have various tools to do so, and finally to get insight and actually deploy or implement what you have done. And in fact, the whole thing creates the value, because that is the main idea, coming up with this value out of this whole data science processing. So that's the basic processing steps that you have here in these blocks. Let's go in to one by one and let's examine one by one. Let's go to the first one, which is our goal. Yes, before we go into any data science projects, or if you want to do some big data analytics, at first we have to know what is our objective. In other words, we have to define our goals. Yes, in fact, we have come up with the right questions. The hardest part is the actual problem definition. Unless we define the problem clearly, we can't come up with the right answers. So in many cases, people spend a lot of time in thinking about this problem and coming up with a question, the right question. Yes, data analysis or data visualization or data modeling, all those stuffs are not that important, but what's more important is defining the problem. Yes. So in most cases, many people spend more time in defining the problem. So that's very vital. Even for example, if somebody is doing his PhD, so for him or her, defining the problem is the hardest part. Once they have come up with a question or the problem, then they can work towards that problem for a few years to obtain the needed result. Yes, this is one of the important steps in the data science processing. Yes, once you defined your problem, you know what you really want, then we can go ahead and collect the needed information that is going to satisfy your question or going to answer your questions. As data collection is the next step. So data collection is the process of gathering and measuring information, and this information is going to help you answer the relevant questions that you are asked. And this data collection, as stated here, can come from many different forms. So for example, maybe you are collecting data, like for example the Twitter data, and you are trying to examine what particular word has been tweeted during a period of time, and you want to examine from which country or the tweet this word. and from this you are trying to establish a relationship and trying to obtain an insight out of this. So that's where you're going to focus. Yes, now you're going to focus on the Twitter data because you are interested in something related to the Twitter based questions. Yes, data collection, as you can see here, there are various places from where we can collect the data. Data collection is the process of gathering and measuring information. So how to collect this data is again another question. So traditionally what we do is like we take survey and we do experiments, we get observations from the experiment sometimes, and we collect observed data, and of course sampling is also considered to be like data. Sample data are collected. So that is the traditional way, and even today we are doing the same thing in many cases. But today we have the liberty of using other open data sets that are available. If suppose our objective is to come up with some prediction based on already existing data, then you can go for the open data sets where you already have those data. Or we can go for the data from sensors, social media, satellite, internet. We have like huge volumes of data, and of course we do have many databases from where we can retrieve data, and if we get or if we have needed permission, we can use other data sources. And sometimes if you need a very specific data, at times you can get those data by paying a small amount. For example, like even Fitbit, the wearable devices, they generate a lot of data, but usually they don't share the data with the customers. In fact, you can get sample data for free, but if you need the whole data, or if you want continuously, if you want to get all those data, in fact that's your data, if you want to get that data, then you have to pay them some money to get your own data. And in fact those data are quite valuable data because that's your own data, and that's it talks about your health, and from there you can in fact see or analyze your own health status. Okay, let's move on to the next category. So next category is the data preparation. So in data preparation process, it involves various elements. For example, starting from the data exploration. So as you have gathered the data, now you have the list of data sets, and right away when you look at those data, you can think of certain things. For example, you can think of, well, what is the average value of this data, or what is the correlation between these two variables, or you can consider like, okay, can I just see this data, I want to visualize this data. Right away you can check it out. Right away, you haven't started the analysis, but even before the analysis you can do certain preliminary analysis, like you can just look at it, and on looking at the data itself you can get some idea about this data that is you're having in hand. Yes, that's simple exploration. You're just exploring what is there in the data that you have just obtained. Then comes the data cleaning process. Well, data that we get from this world is kind of messy or fuzzy, and we have to clean these data. For example, the data, they have some noise in it, and they have some unwanted information. Yes, we have to do certain process, maybe just filtering or data aggregation. Whatever is the data, we have to still look for some unwanted information that might be found in those data. We have to do certain cleaning process, and at times even data are missing. Initially we get those data, some data are missing, or some data are like duplicated. So we do have certain process on how to clean those data, like remove the duplicate data, or if you have some data is missing, try to see how you can compensate for those data. It's not a good idea usually to put zeros instead of those missing data. Sometimes people take mean value, or of course you can do certain simple stats to fill in those missing data, or in certain cases they just take out those set of data that are missing, or those related data that are in line, or that is in line with those missing data. They just remove it and put aside, and that would be considered later on. Yes, data cleaning process is again an important step in data preparation. In fact, we are trying to prepare ourselves to use these data. And at times the data that you have in hand are of different format, and you may have to convert to the format that is easy for you to transform this data. For example, if your data is of in a different domain and you have to transform to a different domain for analysis. I'm not just talking about like if the data is in time domain, convert into frequency domain. Well, there are advantage of doing so, because we do have flexibility of using certain techniques, transformation techniques, to do that, to do the transformation, and then you can actually analyze the actual data. Not only that, your transformation of data should be based on the actual hypothesis that you have in mind. Yes, you can use various manipulation methods to manipulate the data so that you have the data in the right format. At times you may have to reduce the dimensionality of the data. Maybe your data is of 3 dimension and you want to reduce into 2 dimension. At times your data is of 2 dimension and you may have to reduce into single dimension. But we have to be careful, like if you are going to reduce the dimension, of course the complexity of data is going to be reduced, but are we missing out some vital information? That is again a vital question to be asked. Yes, this whole data pre-processing step involves like exploration, cleaning of data, transforming, and the whole thing is kind of data wrangling. In other words, you are kind of organizing the data, you are making the data in right shape. Even like feature extraction or feature selection might be a good tool for us in organizing the data. You may have data, you may see data, some data may have a similar stuff, so you can gather those similar data together or organize together, or similar group of data can be organized together, or sometimes you may have to remove the data that are being repeated again and again, so that you can use the same data to represent the other information. Yes, these are some of the basic data preparation process. It's again, it falls into the data pre-processing, in other words. So then comes this data analysis. So in data analysis, it's very simple, like you have the input data and you choose a technique for analysis purpose, and you are going to build a model. That's it, you are going to have the output. So the key area here is the techniques for analysis. Yes, we have to choose the right way or right techniques for analyzing your data. There are various techniques available, and in this lecture you are going to see some basic techniques that we have in hand. So we are going to see this 5 basic technique. I am not going to explain in depth all these 5 techniques, but in the coming lectures we are going to see some of these techniques in depth. For example, like we have regression, classification, clustering, and these 3 parts are some of the basic techniques that is available. So we are going to look at these 3 parts in depth, and there are more techniques in hand like association analysis, graph analytics. I will explain them in detail, but we are not going to see like various examples on those 2 techniques. Well, let's move on from the various techniques into specifically we are going to look at regression, classification, clustering. That's going to be in the coming classes, but let's see what it is in this lecture. The regression. Regression in generally we are going to talk about linear regression in general for our course. So regression is generally bringing out, or it brings out, the relationship between two variables. So we call one as the independent variable, the other one is like dependent variable, and it in fact gives us a prediction value for the future. You can actually predict what's going to be the values, certain values. Let's see this graph. As you can see this graph, let's look at this graph where you have this linear model, and the linear model has two slopes. One is going upwards, we can call it as like a positive slope. The other one is coming downwards, which is like a negative slope, but these two are kind of linear slope. So you have the linear trend. For example, maybe you can consider the first one going up is like you have the experience in the x-axis and salary in the y-axis. As the number of years of experience increases, your salary gradually increases. The second one you can consider as like, for example, you have a car, the second-hand cars, and you want to buy the second-hand cars, and you can consider maybe the number of years the car used in the x-axis, or the number of miles or number of kilometers it went in the x-axis, and the price in the y-axis. As the number of years is less, your price of the car is higher. As the number of years increases, the price would go down, or in other words, the number of kilometers it has gone. So that's a very basic thing, but from this trend you can actually calculate. For example, if you consider the number of kilometers the car has gone, and in the x-axis, let's see here, suppose this is the kilometers that you have in hand, and suppose you want to know what is the price of a car at this point of time. Let's say here is like maybe 100,000 kilometer, and if you want to know the price of the car, you can just go and hit this line here. Or if you want to know the price of the car at this level, you can just hit this line. So this is going to be your predicted value. So approximately your car value is set at this level. So that it's kind of a prediction where we can try to see what is the value of the car that you are going to buy. So you don't want to buy an undervalued car, or like you don't want to buy, if of course there is an undervalue, then there might be some reasons for that, so you may have to consider that. And definitely you don't want to buy an expensive car. You want to give the right price, the right market price of your car. So the same applies to the salary as well. So if you are having a number of years of experience, then you are going to expect a certain level of salary. Yes, that's the expected value. The same way in this regression analysis, later on in our course we will also see in detail, like with examples, or specifically how we can mathematically model this system, and then we can predict the upcoming values for certain examples, for certain application. And of course we do have sometimes come up with some non-linear relationship, and we will not consider non-linear relation or non-linear parts in our course, as in fact there are ways to model such factors. Sometimes the whole model looks like non-linear, randomly dispersed. Yes, we do have methods to establish a relationship between those models and try to predict what's going to be the future of certain non-linear relations. Then comes the classification. So here as you can see this picture, there are two sets. One is in black, the other one is in white. So the main objective is to classify these two groups. So in order to classify these two groups, here we have the H1 and here you have the H2 and here you have the H3. So we can clearly see that H1 and H2 classify this group quite rightly. It can split up this group quite rightly. H3 is not clearly classifying these two groups, which means that H3 is not a good classifier. So here we are talking about a linear classifier. So this achieves by making a classification decision based on the linear combination of the characteristics. So we can say that H2 is a better linear classifier because H2 lies quite far from both groups, whereas H1, if you see H1, we can see that H1 is quite close to both these values. For example, here it's very close to the section there, as well as here it's very close to this part, the Y group, as well as the black one. So we don't consider H1 as to be the best linear classifier because our main objective is to classify the two groups. We don't want this classifier to be closer to any of these two groups. Let me give an example. For example, if you want to have a review for movies, you are talking about movie reviews, you want to know whether this movie is good or bad, and if you want a classifier to classify this movie as good movie or bad movie, then you like to have a classifier that clearly shows you whether this is, well, this is a good movie and this is a bad movie. You really want to know the line that classifies these two categories. We don't want a classifier to be closer to, like, say for example, it says, okay, this is good movie, well, this is also a kind of bad movie. Well, because we are talking about a linear classifier, we want a definite classification, but there are other classification models where we get, as we go deeper into this classification, there are some complex models where we can define multiple objectives, and then we can clearly see whether we can able to classify this non-linear classification. Since we are talking about linear classification, we want a definite cut between the good and bad. So we will see in depth with various applications of maybe movie reviews or restaurant reviews. We can actually easily use simple algorithms to classify. For example, maybe we can try to extract the text, and then from the text we can see whether the text has the movie reviews have the sentences, and the sentences would have words, and from these words we can see whether this word is a positive, it referring the positive words or the negative words, and eventually we can classify whether this is a positive one or the negative one. Then comes the clustering part. Clustering is kind of grouping together, grouping things with same set together. In other words, we can consider like you have group of people, and among this group of people you want to cluster group of adults together, group of children together, group of say old aged people, and you are defining certain limits. For example, for children or teenager, you are setting limits like, okay, children are from 2 to 12, and teenagers are from 13 to 18, and adults are from say 19 to 35, and old ages from like 36 and so on, 36 onwards. So those values you can define, and based on that definition you can provide clusters. In both classification and clustering, we can set threshold values to determine our the place or objective. So as you can see here in this picture also, we have the classified or in other words we have clustered actually. Where 3 clusters are clearly seen, and there are some outliers for these 3 clusters. As you can see, there are some red values over here. It's kind of an outliers, we can say it as an outlier, and then the green one over here. We will see how to examine or how to handle with those values later on. Since this is just the basic introduction to the whole data analysis process, and we are dealing with regression, classification, clustering, and so on. Let's look at one more part here. This is the association analysis. Today, yes, the business retailers are using these methods to increase their sales. For example, as you can see from this picture, someone who buys the milk, whenever he buys the milk, 71% time he also includes bread, and 43% time he includes eggs, and 29% time he includes toilet papers. So now you are coming up with a relationship, an associated analysis, though toilet papers and like maybe eggs or bread are not much related to one another. Based on the purchase history, we can see there is an association between these parameters. So that's how in marketing field, for example, in the retail store, what they do is like they keep the bread as well as the milk next to each other, as well as the egg. So it's easy for the customers to pick up all those stuff right away, which means that they don't have to go from one place to another place. In the meantime, as they go from one place to another place, sometimes they forget things and they may not buy in your store. So to make them buy in your store, you make this analysis and then just keep these things next to one another, and so that the customers, they are easy to identify their products and they just take and buy it out. So that's good for those businesses. Yes, this kind of analysis is very getting popular in the business areas. So that's a little bit different from the classification and clustering schemes. And you will also notice that this analysis, association analysis, not only have association with related product. There are times where we have come across with analysis that has association with completely different products. Say for example, the products like beers and diapers, they are completely different products, but still they have found that there is some relationship between these two products, especially during the weekends. Yes, when you make certain analysis, you can come up with the right pattern, and then we can see the right association between this product. And you have this graph analytics. Yes, graph analytics are used to connect, or it used to establish the connection between two entities. So these two entities can be two friends in a social network, or they can be like two scientists who are working on the same field, or they can be two students who are studying in different schools in different country. Yes, there are various ways we can establish such connections, and in fact these days the whole world has been kind of connected. So when you talk about the social media connections, people say that the whole world is connected and there is a 6 degree of separation, and because of this various social medias like LinkedIn, Facebook and ResearchGate and so on, there are a lot of other social medias available, and because of these medias we are in fact reducing this connection from one person to another to less than the 6 degree of separation. Yes, this graph, once you are getting connected to these graphs, actually you can use various graph algorithms to solve various problems. Even you can optimize the search, for example, or you can optimize the shortest path between these two nodes. The nodes can be a person if you are talking about a social media, or it can be a place if you are talking about different cities are connected by means of these edges. Yes, there are various applications of this graph analytics. Yes, once we done with this data analysis, we make sure that our data analysis works well. So we should validate our techniques. For example, maybe we use the regression methods or a classification method to build a model, and from this model you are trying to establish a relationship, and then we have to validate and we have to evaluate to see that this model is the right one to be used. So we can double check and verify our data analysis. So as far as the results are concerned, yes, we can establish a visualization of our results. So there are a lot of tools available for doing so, like the two popular tools that are available for data visualization is the Tabular and Power BI, and even Excel is still a good tool. Even many people are using this Excel. Many people even, in fact, they don't know the exact significance or the power of Excel. Excel can be used to certain level for establishing this data visualization. They are very useful tool as well. So once we come up with these data and all those stuff, then in fact we have to get the insight from this whole story. We had the data, we told a big story, and this story, does this story has some insight out of the story? What is the moral of the story that you are telling? Yes, we have to come up with this insight, and based on the insight you are making the right decisions. Okay, you know that because of this association analysis, I have come up with the strategy that I am going to place what is that? We have this toilet papers and eggs next to one another. Is this decision the right one to do? Well, we need insight. That's where the human input comes in. We need experts. We need those people who have domain knowledge. Based on all the analysis that you have done, we have to give the right input, get the insight. And once you have this insight, now the next goal is to deploy, take action. We have to take action in sense that, okay, let's do it. Let's keep the toilet paper and the eggs next to one another. That's the deployment action that you are taking, and see what happens. Well, at times you may have to go back and do this whole process of data analysis again with certain modification. Yes, that is kind of iteration. You get some feedback from the action that you have taken, and based on the feedback you may have to remodel your whole system sometimes, so that you get the right value behind this insight. So that's our goal, right? We have to get the right value behind this insight. The overall objective or overall goal is that, does our question that we have raised initially before even starting the whole data analysis process, is it really a good question? If it is a good question, then this question has to bring out some value, some innovation, some time saving, energy saving, or even life saving. Yes, that is the final goal of our whole data analysis process. As today we examined very basics of data analysis. In fact, we saw various steps involved in data analysis process. We saw that data collection is an important step. In fact, before data collection we have to define our objective and come up with the right question. Then you collect the related data that would answer your question, and then you are going to the next step of data preparation, which involves data pre-processing. You're trying to explore the data, and then you're going to model the data as well. So that's where the data analysis comes in. We saw simple models like regression, classification, clustering, association analysis, and graph analytics. Finally, with this analysis result, you are trying to see some insight out of it. And does your insight is good enough to take the action? And after you take the action, and if you didn't get the real value or the output from this, try to remodel the whole thing. It's kind of iterative, and then come up with the right analysis again and refine it, and take action again, so that you can come up with the value that you're looking at, creating the value. Yes. So that's the end of today's course, and we are looking forward to see you in the next class. Okay, till then, goodbye.